After gravitational force, now let us perform another activity on frictional force. In this activity, keep 3 or 4 books, one above another, on a table. Pull the books using a spring balance. Now, insert some pencils at the lower surface of books and again pull the books. You feel it easier to pull the books after inserting the pencils, isn't it? What is its reason? Students, when a body moves or tries to move on the surface of another body, a kind of force is created between the two bodies. This force is called frictional force. That is why you feel it easier to pull the books after inserting the pencils. All the bodies have surfaces which are not perfectly smooth. Although it may appear to the eye as a smooth surface, it is not really perfectly smooth. A magnified view of a surface as shown in figure. Look at the figure. You can see a magnified view of a surface. In these surfaces, there are projections and depressions. A smooth surface has fewer projections and depression in comparison to rough surfaces. When two solid bodies are in contact with each other, the projections of one fit into the depression of the other. This gives rise to frictional force. Thus, when a body moves or tries to move on the surface of another, frictional force comes into existence. First, frictional force depends upon the nature of two surfaces in contact. Let us perform an activity to prove this. Students, place a wooden block on the surface of a table. Then attach a spring balance on it. Then measure the force necessary to slide the wooden block over the table. Again, place the block on a surface of large pane of glass and measure the force required to slide over it as shown in the figure. What will you observe? Does the spring balance show less reading when the block slides over the glass? Students, this proves that the friction depends upon the nature of the surfaces in contact. The frictional force is more on the rough surface than on the smooth surface. Dear students, frictional force increases as the weight of a sliding body increases. To prove this, again, let us perform an activity. In this activity, we have to place a wooden block on a table and then measure the amount of force required to pull it on a spring balance as shown in the figure. Again, add a similar block on the top of the previous block as you can see in the figure. Again, measure the force. What will you observe? Does the spring balance show different reading when the weight is increased? Of course you do, isn't it? Thus, we can say that frictional force increases as the weight of a sliding body increases. Another nature of friction is that frictional force does not depend upon the surface area. Here is an activity to prove this. Force does not depend upon the surface area. Here is an activity to prove this. Students place a wooden block horizontally on a table and measure the force to move it with a spring balance as shown in the figure. Place it vertically now and measure the force to bring it into motion. What do you observe? Students, in both cases, the force shown by the spring balance is the same. This indicates that frictional force is independent of the surface area. Students, due to the friction between the feet and the ground, it is easier to walk. It would be impossible to walk without friction. The movement of cycle, motorcycle, car, bus, and truck is possible because of friction between the tires and the surface of the road. We are able to ride because of frictional force between the pen and our hands. Students, friction in machine wastes energy. Friction produces heat in the machines, which may damage the machine and reduce its efficiency. In order to reduce the friction, oil or grease is applied on different parts of a machine. Look at this simple activity. Rub your hands for a while. Do you feel warmth in your hands? Can you explain what could have caused it?